Hi everyone, we're going to be solving equations by factoring. So you're going to get lots of factoring practice on this particular lesson. We're starting out with something called the zero factor property. So the zero factor property basically says if a times b equals 0, then either a is 0 or b is 0. And this holds true even if you have more than two factors, so it can be two or more. What we're basically looking at here is the fact that we're trying to solve two little equations, basically x minus 7, for instance, times x plus 2. This is an equation in factored form. So we simply take the x minus 7, set that equal to 0, the x plus 2, and that's also equal to 0. And then this is solving. To solve for x, we would add 7 to both sides. So x equals 7 is one of our solutions. And then we would subtract 2 on the second factor, the second factor is x plus 2. We would subtract 2, and then x is equal to negative 2. So these are our two solutions. You can write these just with a comma, so you could write it this way, negative 2 comma 7. It doesn't really matter which order you put those in. So the same thing holds true for this next equation that's already factored, so we don't have to do the factoring part yet. We set 5x plus 1 equal to 0 and x minus 3 equal to 0. Now I like to see this part that you actually set these equal to 0. I don't necessarily have to see the part where you solve each one, because I know many of you will be able to just do this in your head automatically. So for instance, for 5x plus 1, to solve we would subtract 1 and then we would divide by 5. So that's going to be a solution of negative 1/5. And then on the second one we would add 3. And so my second solution will be a 3. So if you need to solve those, if you need to show that to make sure that you don't mix up signs or anything, that's certainly fine. If you understand how to that you have to subtract 1, divide by 5, then that's also fine. Leave these in fraction form if they are fraction answers. Okay, so sometimes we're going to have a common factor. That's what happened in this case. There was a common factor of 8 in the original equation. And so whenever you factor out the 8, then you may be wondering, what do I do with this 8? Well, 8 is not going to give you another solution. So if the 8 was a variable, if there was a variable with the 8, then we would have to set that equal to 0. But in this case, we can kind of just ignore it. If you multiplied it back in, you would have 24x minus 32, and you would get the same solution. So in this case, we can just set 3x minus 4 equal to 0, or 2x minus 7, and then solve for x in both cases. So on the first one we would add 4, then divide by 3, so x would be 4/3. And on the second one we would add 7, then divide by 2, so that would be a 7/2. Excuse me. And I would like to show you then that you can check these solutions because on the former page I didn't have as much space, and I have more space on this one. So if you go back to your original equation and substitute in, let's do this in a different color if I could find my colors. Hold on just a minute here. Okay. So for some reason when I'm in this program sometimes I lose my ability to change colors, and so I'm going to hold on, I need this whole thing. So I'm going to put in a 4/3 times my 3, and then subtract 4, and 2 times 4/3 minus 7. And so then I would just check both of these. So you can see if I multiply 3 times 4/3, it's 4. 4 minus 4 is 0, so now I have 8 times 0. On the second one, that's 8/3 minus 7. And so I have to think about this. 8/3 minus 7. That would be 21/3. It doesn't really matter because we're multiplying this by 0, right? And so then I would have a negative 13. But regardless, this equals 0. And then if we check the second one, we're going to have the second set, the 2x minus 7 will equal 0. So we can see that this does check. And when you're factoring, you just go back to your original equation. So if it's not already in factored form, you would check it in your equation that was not in factored form originally. All right. So now we get to the point where we have to also factor before we can solve. So in this case, we're going to factor and the y squared minus 10y plus 24. Now when we were talking about factoring, we were finding multiples of 24 that have a sum of negative 10. And then in this case we can go directly to factored form because the leading coefficient is 1. So we'll be able to just put what we find for these two parts in there when I find the factors of 24. And so there are several factors of 24, but the two that I need are negative 4 times negative 6, because negative 4 plus negative 6 is negative 10. So it will be y minus 4 times y minus 6. And then I set those equal to 0, or y minus 6 equals 0. So my two solutions are 4 and 6. This would have been an easier one to check than the previous one when I had fractions. So that's the whole process. Oh, and I didn't mention on these steps. Notice the first step says write the equation in standard form so that one side of the equation is equal to 0. You are going to have times when your equation is not equal to 0, and that's very important that you go ahead and rewrite it. So you want to get it set equal to 0 to be able to solve and also to be able to factor. So equal to 0, then factor, set each factor equal to 0, solve, and then you can always check. And checking is one of those things that's just an extra step that might be helpful, especially when you're doing something that counts for points. Okay, like on my lab. All right, so here's the next one. Now, this is one that you would probably, or possibly some of you will choose to factor this using the AC method or the grouping method, as our book calls it, the grouping method. And so you would multiply 3 times negative 14. So we're going to find factors of negative 42 that have a sum of negative 1. And I'm going to show you this method partly just as a reminder and on factoring. So I'm looking for these two factors that just have a difference of 1, and that's going to be negative 7 and positive 6. Because when I add negative 7 and 6, I get negative 1. So it fits the criteria for both of the parts that I need. Now I replace my middle term with negative 7x and 6x. And then this is where I group and factor. So I'm going to split this into the two pairs, right? And then take out my common factor in each one. So the first one, 3x squared minus 7x, has a common factor of x. And when I factor that out, whoops, I might want to put a 3 in there, I'm going to have 3x minus 7. And then on the second two, they have a common factor of 2. And then that leaves me 3x minus 7. In factored form, this will be 3x minus 7 times x plus 2. Remember that you are factoring out your common binomial of 3x minus 7, and then the remaining binomial will be the x plus 2. I set each of these equal to 0 then. And then solve for x. Okay, so I'm going to add 7 and divide by 3. So one of my solutions will be 7/3. And then on the second one I would subtract 2, and that solution is -2. You can always double check and make sure, right, if I put 7/3 back into 3x minus 7, that will equal 0. If I put -2 on the x plus 2, that's going to equal 0. So those are my solutions. Alright, so I'm going to stop this video, and I like to try to keep them not too long, and I don't want to go past 15 minutes, so we're going to stop here, and then I'll pick this up right where I left off for the next video.